Early 1945, in the icy waters off Japan's coast, an American F4U Corsair met its unexpected fate. The aircraft, crippled by an engine failure during combat operations, plunged into the cold Pacific, forcing its pilot to eject moments before impact. Within mere hours, Japanese patrol boats converged on the site, rescuing what remained of the fighter. What they found would become one of the most consequential intelligence opportunities of the war's closing months. For nearly 3 years, Japanese pilots had clashed with the Corsair over the Solomon Islands, Rabaul, the Philippines, and eventually over the home islands themselves. Time and again, they had learned to respect its extraordinary speed, its overwhelming firepower, and its seemingly indestructible structure. Yet until this moment, no Japanese aviator or engineer had ever possessed an intact example to study up close, to measure meticulously, to test thoroughly, and to grasp the scale of the technological gap. The Corsair was more than an aircraft. It was a symbol of industrial prowess and engineering mastery. Japan's confrontation with it marked a moment of painful realization, a nation's stark awakening to the sheer scope of American manufacturing, engineering, and design sophistication. When the Japanese salvage crews retrieved the fighter, it wasn't merely about recovering a downed plane. It was about uncovering a treasure trove of technical knowledge. From the distinctive inverted gullwing to the gargantuan Pratt and Whitney R2800 double wasp engine, every detail of the Corsair's construction revealed insights into precision, material science, and structural ingenuity that Japanese engineers had only theorized about until then. This fighter embodied the culmination of American design philosophy, a product of relentless innovation since 1938, when the Navy's Bureau of Aeronautics demanded a single-engine fighter capable of exceeding 400 miles per hour. At a time when most aircraft barely scraped 350 mph, the Corsair's development represented audacity, foresight, and meticulous attention to engineering detail. Designers Rex Beisel and Chance Vaught had chosen the largest and most powerful engine available and built an aircraft around it, combining speed, firepower, range, and durability in a way that Japanese aviation had struggled to match. The inverted gullwing design, created to accommodate the enormous 13-foot 4-inch propeller while maintaining structural efficiency for carrier operations, instantly distinguished the Corsair in the air and illustrated American problem-solving at its finest. From its maiden flight in 1940 to the Corsair's combat deployment in 1943, every facet of the aircraft was carefully calibrated, from engine power to aerodynamics to armament capacity, producing a fighter capable of excelling in conditions where conventional Japanese tactical expectations fell short. Even its early combat debut, though marred by the heavy losses of the St. Valentine's Day engagement, quickly became a classroom in adaptation, teaching American pilots to exploit the Corsair's strengths with boom and zoom tactics, transforming a fragile beginning into legendary dominance. By mid-1944, the Corsair had earned a fearsome reputation across the Pacific. From hastily constructed coral airstrips in the Solomon Islands to the brutal campaigns in the Philippines, this fighter's resilience was legendary. Its rugged construction absorbed damage that would have downed lighter Japanese fighters, while its 650 caliber Browning machine guns, meticulously engineered with immense ammunition capacity, delivered firepower the enemy could scarcely counter. Later models carried 420 cannons, yet many pilots continued to favor the reliable .50 caliber guns for their balance of lethality and consistency. Beyond air-to-air combat, the Corsair excelled as a fighter bomber, carrying 1,000-pound bombs, high-velocity rockets, or napalm canisters, supporting amphibious operations with precision and relentless pressure. During the Okinawa campaign, infantrymen famously dubbed them the Angels of Okinawa for their indispensable ground support. While Japanese pilots witnessed these advantages firsthand, the full extent of the Corsair's brilliance was concealed behind its engineering. A true understanding required a detailed, technical examination, which became possible when the salvage crews delivered a relatively intact Corsair to Yokosuka Naval Air Technical Arsenal and the Army Aviation Technical Research Institute at Takekawa. Unlike prior damaged captures, this fighter offered Japanese engineers a complete picture of American precision manufacturing. The aircraft had endured saltwater immersion, yet its airframe remained unscathed, allowing for an unprecedented close study. Wingspans, lengths, heights, and the intricacies of the inverted gullwing were meticulously documented, revealing both aerodynamic ingenuity and manufacturing sophistication that had eluded Japan. See factories. The discovery that significant portions of the Corsair's wings and control surfaces were fabric-covered surprised many specialists, as the material was carefully treated to provide strength, weatherproofing, and weight reduction, allowing critical aluminum resources to be allocated to high-load components. Internal structures, including the massive forged wing spars, precision-cut aluminum ribs, and integrated armament bays, displayed a level of quality and consistency far beyond what Japanese manufacturing could reliably achieve during the war's final years. Even small fasteners and secondary systems reflected exacting standards. Every measurement, every component, every finish demonstrated a discipline and industrial capability that Japan's wartime constraints, material shortages, conscripted labor, and constant bombing could not replicate. The meticulous armament installation, with interconnected feed systems, ejection mechanisms, and precision-engineered Browning M2 machine guns, illustrated reliability and integration at a level that Japanese engineers admired yet struggled to match. Armor plating, bullet-resistant glass, and cockpit protection further revealed a philosophy of performance without compromise, a principle made feasible by the Corsair's exceptional engine power and structural design. This examination went beyond curiosity. It was a window into why Japan, despite its courageous pilots and skilled technicians, had been technologically outpaced. At the heart of the Corsair's superiority lay the Pratt Whitney R2800 double wasp engine, an 18-cylinder radial powerhouse producing over 2,000 horsepower. Japanese engineers, though familiar with similar engines, had never encountered one in such intact, analyzable condition. The precision machining, tolerances measured in thousandths of an inch, and superior metallurgy revealed capabilities well beyond Japan's reach at the time. Pistons, connecting rods, crankshafts, and rotating assemblies demonstrated consistency, and surface finishing Japanese facilities could scarcely match, while the two-stage supercharger system illustrated both ingenuity and the depth of American manufacturing sophistication. The engine's reliability and continuous power output, coupled with a massive variable-pitch Hamilton standard propeller, made the Corsair a benchmark in aeronautical engineering. Examining auxiliary systems, from landing gear to fuel systems, from cockpit instrumentation to electrical networks, Japanese technicians confronted an overarching truth. The Corsair was built with meticulous care and systemic precision. Each component, no matter how small, reflected planning, testing, and quality control that emphasized longevity and reliability alongside raw performance. By 1945, Japanese factories struggled with inconsistent material quality, makeshift substitutions, and disrupted supply chains. Skilled labor had been drafted, and the cumulative stress of war meant that even contemporary Japanese designs could not maintain uniformity or precision. Confronting the Corsair's engineering was a sobering experience, revealing that their ingenuity and courage, remarkable as it was, could not compensate for systemic industrial limitations. The examination occurred against the backdrop of impending defeat. American B-29s relentlessly devastated Japanese cities, naval power had been shattered, and Okinawa and the Philippines had fallen. The study of the captured fighter was no longer a tool for operational advantage. It became a measure of reality, a tangible demonstration of the technological and industrial chasm that had developed over years of conflict. Technical reports, measurements, and photographs meticulously documented by Yokosuka and Takakawa engineers encapsulated this painful truth, showing that American production capacity, research investment, and engineering culture had created a gap too vast to bridge in the remaining months of the war. Even the repairs attempted to restore at least one captured Corsair to flying condition highlighted the seriousness of Japanese efforts, though whether flight testing occurred remains uncertain. The Corsair's legacy extended far beyond the war. It fought in Korea, served in colonial conflicts for several air forces, and completed its final combat missions in the 1969 Soccer War between Honduras and El Salvador, a testament to its enduring design. For Japan, however, the 1945 encounter represented a profound reckoning. Engineers and scientists who had battled material shortages and industrial limitations during wartime now confronted American technological mastery in a way that shaped post-war philosophy. The lessons learned from examining the Corsair influenced a generation of Japanese manufacturing, laying the foundation for modern principles of precision, quality, and continuous improvement. The fighter's recovery was more than a historical artifact. It embodied a stark, irrefutable illustration of what technology could achieve when paired with sufficient resources and industrial expertise. Japanese engineers had witnessed firsthand that courage and skill, while vital, were insufficient against the industrial might of a well-organized adversary. The reports they produced, preserved by American occupation forces, now serve as silent witnesses to a pivotal moment in aviation history. Though the Corsair itself was eventually scrapped in the post-war chaos, its lessons endured, lessons about precision engineering, sophisticated manufacturing, and the extraordinary potential unlocked by industrial capacity, scientific knowledge, and meticulous design. In confronting this single American fighter, Japan grasped the full scale of the technological chasm that had opened during the war years, a gap measured not in propaganda or battlefield claims, but in aluminum alloys, precision forgings, and tolerances that spoke louder than any words about the true nature of American industrial power. These insights, painful as they were at the time, became the foundation for Japan's remarkable post-war resurgence in industry, technology, and engineering excellence.